Welcome to Jigyasu Educare International online teaching support program. Dear students, today we are going to discuss effect of rotation on acceleration due to gravity. The prerequisite before we enter into learning of effect, we must know acceleration due to gravity is represented by symbol g, which is given by capital G, the constant of universal gravitation, times mass of the earth over radius of the earth r, square of the radius. Here we are considering effect on the surface. This formula is for surface. Now we are going to consider a particle of unit mass placed at position Q. This is our equator. This is pole. We can call it P, we can call it E. This is our center O, center of the earth. OQ is going to be radius, which is R. Now, the point Q is at altitude lambda. This makes an angle lambda with the horizontal. Therefore, if we call this point M, then angle MQO should be lambda as well. So let me mark it lambda. Now the prerequisite which is required here, that component of r, because small r is the radius of circular orbit in which this unit mass at Q is rotating. Is revolving with the sun. Is revolving. This is at Q. Now remember, R is unknown quantity. In physics, we replace unknown quantity by known quantities. Known quantity here is radius of the earth. So small r can be represented as component of radius of the earth, r cos lambda. I hope you remember it. There's a way you can remember. Alongside angle, it is always cos component that we take. This is just a mnemonics to make you recall it quickly. So component is required. This is one thing. Second requirement here is centripetal acceleration AC, which is given by m omega square r, where r is the radius. As I told you, r is a known quantity. So r we are supposed to change to capital R. So from 1, if I replace this r by expression given in 1, then our equation can be written as AC equals m omega square capital R times cos lambda. Okay. Now you are aware that in case of circular motion, centripetal force is a must condition. That means in absence of centripetal force, particle or the object cannot revolve in the circle. if we assume particle as of mass m, then centripetal force AC will be acting towards qm, direction will be q to m. Who will provide this acceleration? Centripetal force is a demand, it is not supply. Supply should be given by some of the fundamental forces. So in this case, gravitational attraction, the pull of the earth on the mass body, should be the only source which can provide centripetal force. If centripetal force is not provided, it can throw off in tangential direction immediately. But the body is not being thrown out because it's being attracted by the earth towards its center. So, if I to write, alright, now this centripetal force is being provided by gravitational attraction Fg. So Fg, which acts towards qm, direction is qo, sorry, not qm, qo, will be given by mg, right? Actual mass. But actual mass, actual weight of the body is being affected because part of it is being eaten up to provide required centripetal force. So a modified resultant force Fr will come into play. Fr will be Fg centripetal, gravitational pull minus component of, if I put m, then it should be Fc. Now Fc cos lambda, this Fc is acting towards qm. So component of Fc that will be acting along component of Fc along qo, this qo would be given by Fc cos lambda. So now resultant pull force, as I said again, I'm going to tell you again that gravitational pull, part of gravitational pull is being used to provide required centripetal force. So Fr equals Fg minus Fc cos lambda. I hope this point is clear. Let me repeat. Without centripetal force, mass m would fly off, would not be sticking to the surface. And Earth is continuously rotating with speed omega, which is constant. So now we can write equation in the form mg dash, the new value of weight due to rotational effect we are including in it. Mg, this is the actual weight in case Earth stop rotating or there is no rotational effect, and F centripetal we know m omega square r cos lambda times cos lambda. So this is the way now. If we take m common and cancel it out, we will be left with g omega square r cos square lambda. So this is the desired expression. This is the effect of rotation on acceleration due to gravity. Since quantity being subtracted is a positive quantity, omega, the angular speed, is positive, r, the radius, positive, angle is also positive because Maximum you can go starting from equator to pole. That is your orientation in first quadrant only. So now let us discuss where this effect is maximum and where this effect is minimum. So if you look at this, this is our equator, this is angular position at altitude lambda, and this is pole, right? So if this side is here, it is 0, it is lambda here, and if it reaches here, vertical position, it is 90 degree. So it means at pole, if we talk about pole, at pole lambda is 90 degree, and you are aware that cos lambda will be 0. So this subtracting factor, the factor that causes change in the gravity, will be 0. So G dash at pole will be G, the normal case. That means there is no effect of rotation on the objects lying on the pole. That means G at pole is not affected by rotational motion of the earth. Let us talk about at equator. At equator, the lambda, as I said, this position vector, if it changes to, it comes over here, angle will be 0. So at this position at equator, lambda is 0. That makes cos lambda 1, which is maximum value. Therefore, the decrement factor omega square or cos square lambda is maximum. So there will be maximum effect on acceleration due to gravity at equator. So G dash is G minus omega square R. Cos lambda becomes 1, then G dash equals G minus omega square R. That is at equator. So the effect of rotation is maximum on equator. Questions are generally asked based on this. If Earth stop rotating, how the G on the surface of Earth will vary? And they can give you at pole or at equator. So at pole, there will be no change. Weight of the object will remain same. So at pole, no change. When? In which situation? When Earth stop rotating. So let me write here, if Earth stop rotating, then at pole there will be no change in G, and at equator maximum increase in the value of G will be seen. So things to remember, let us, before we conclude our session, let me give you a quick review. See, you know, you are familiar with the force of gravity. Gravity is the name given to the force of attraction between Earth and Mars body. For any other planet, we do not use gravity. And weight of an object is given by mg. G varies due to various factors, like at height G is less, at depth G is less compared to at the water level or sea level. Effect of rotation is our today's topic, and we saw it already. Started with G equals Gm over r square. This is the position, angular position of a particle of mass m kept at point Q. This particle will also be rotating with angular speed omega, which is expressed in radian per second, along with the earth. And any rotating body requires centripetal acceleration. So first challenge is the new radius, and in physics we don't want any unknown quantity, so we have replaced unknown quantity by known quantity, the radius of the earth, in terms of angular position. And this is going to be centripetal force required, and as I told, centripetal force is a demand. We need somebody to give it. So gravitational pull provides required centripetal force. Component of centripetal force, R is replaced by R cos theta here, and gravitational force on the object is given by mg. Component of Fc along QO, this is QO, along this direction, the component of this Fc is needed. That will be a reduction factor. So we can make a net equation. Resultant force of attraction mg dash is equal to force of attraction if earth does not move, does not rotate, minus centripetal force, component of centripetal force. Taking m common, we got the expression. And lambda is maximum 90 degree at poles, and cos lambda is 0, hence effect of rotation is 0 on the earth, on the pole of, and G at pole is equal to actual G. Whereas at equator, angle lambda is 0 radian, cos 0 is 1, therefore the decrease factor is maximum, and G dash is lesser than, so GE is smaller than G at pole. So I hope today's discussion was useful to you. Thanks for watching.